Imagine a computer so powerful it could cure diseases, tackle climate change, and maybe even unlock the deepest secrets of the universe. Well, that's the promise of quantum computing, and believe me, it is closer than you think. But what if that exact same power could also become our single greatest threat?
Okay, let's just dive into this for a second. We're talking about a total revolution in medicine, where we could literally design life-saving drugs molecule by molecule. Or a green energy revolution, with hyper-efficient batteries and brand new materials to capture carbon right out of the air. We could even finally start to unravel the biggest mysteries of the cosmos. I mean, this is a complete game changer.
But with any incredibly powerful new technology, there's always a flip side, right? What if the very thing that promises to solve our biggest problems also creates our biggest vulnerability? That amazing power, well, it poses an urgent, almost existential risk to the security that underpins our entire modern world. And this, right here, this gets to the absolute core of the problem. You see, the digital locks we use for everything, from our online banking to our private messages, are all based on a really clever trick. They rely on math problems that are practically impossible for today's computers to solve. But for a powerful quantum computer, those impossible problems are child's play. The locks that we trust every single day, they're going to simply shatter. And look, this isn't some abstract, techie issue. This is about protecting the very fabric of our digital lives. We're talking every single financial transaction, every private conversation, every company's trade secrets, and every piece of classified government information. All of it is protected by locks that are right on the verge of becoming totally obsolete. Now, you might be thinking, okay, this is a problem for the distant future. But the thing is, the threat is already here. And it's a new kind of threat, one we've really never faced before, one that actually weaponizes time itself. So how is that even possible? Well, the attack is called Store Now, Decrypt Later, and it's a simple but honestly a terrifyingly effective strategy. Right now, adversaries are stealing massive volumes of encrypted data. They're just hoarding it. They're creating this huge digital treasure trove, just waiting for the day they get a quantum key that will unlock every single bit of it. This timeline breaks down exactly how this whole attack will unfold. Phase 1, the data theft, is happening right now, silently, on a global scale. Phase 2 is the arrival of what's called a cryptographically relevant quantum computer, or a CRCQ. That's a machine powerful enough to break our current encryption. And then, Phase 3. That's the moment of truth, when years, maybe decades of stolen secrets are all revealed at once. So the most crucial point to get is this. Every piece of data with long-term value that gets stolen today is a ticking time bomb. The clock didn't start on the day a quantum computer gets built. No, it started the second that data was copied, just waiting for the quantum key to set it all off. Okay, but we are not defenseless. While this threat has been growing, the world's top cryptographers have been hard at work on a new kind of shield, one designed specifically to withstand the raw power of a quantum attack. The solution is called Post-Quantum Cryptography, or PQC for short. Now, these aren't just stronger versions of our old locks. They are entirely new types of algorithms built on totally different math problems that we believe are just as hard for quantum computers to solve as they are for the computers we use today.
And this isn't just some theory either. After a global, multi-year competition, the U.S. National Institute of Standards and Technology, that's NIST, has already standardized the first generation of these PQC algorithms, so the tools are ready. Now it's time to actually use them.
Companies like Google are already leading the charge. Their whole plan really hinges on 3 key pillars. First, crypto agility. Think of it like changing the locks on your house. You want to do it quickly, right? Without having to replace the entire door. It's the ability to swap in these new quantum-resistant algorithms without breaking everything. Second, secure your own house first. And third, help the entire neighborhood upgrade their security too. But this is way too big of a challenge for any one company to solve. It's going to require a global effort, a really coordinated response from our leaders and policymakers. So here are 5 key actions we absolutely need to take to secure our collective future. First up, we need to build a real sense of urgency across all of society. See, this isn't just a problem for tech companies. It's a huge problem for our power grids, our hospitals, our financial systems. We have to identify the unique barriers these critical sectors face and help them make that quantum leap to safety. Second, we have to protect the future of innovation itself. As we build the next generation of artificial intelligence, we're creating these vast new datasets and incredibly powerful models.
If we don't secure the very foundation of AI with PQC from the start, we're basically building a beautiful, intelligent house of cards.
Third, and this is a big one, we have to work together.
A fragmented approach, with everyone using different, unvetted standards, is a recipe for disaster. Adopting a unified, global benchmark like the one from NIST makes sure we're all rowing in the same direction and not leaving any gaps for attackers to slip through.
Fourth, it is way past time to modernize our public systems.
So many government agencies are running on old, outdated technology that's just incredibly difficult to secure. By moving to the cloud, they can leverage the cutting-edge PQC work that's already being done by major providers. Honestly, it's a massive shortcut to becoming quantum resistant.
And finally, number 5, we absolutely cannot afford to be caught by surprise. Look, we don't know exactly when a cryptographically relevant quantum computer will arrive, but we know it's coming. We need a constant, open dialogue between our leaders and the experts on the front lines so we can anticipate and adapt before it's too late.
Ultimately, this is about so much more than just security. It's about ensuring that this next great technological leap forward leads to an era of unprecedented progress, not catastrophic failure. It's about harnessing this incredible new power for good.
The quantum revolution is coming. The tools to prepare are here and the roadmap is clear. The only real question left is, will we be ready for it? The future of our entire digital world really depends on the answer.